Hey everybody, this is Larry. This is March 28th. Well, I mean, it's March 27th here, but the 28th day of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. So I came here so that I could click on the Happy Leetcode button, get 10 Leet coins. It adds up, I suppose. Yeah, hope everyone's doing okay. If I look very tired, it's because I am. I've been doing... I guess I'm 50 hours into my fast, roughly speaking, maybe 49, I don't know, whatever, right? so I'm a little bit tired, but not from that per se. Actually, the fasting has been giving me a lot of energy, which, it's supposed to do. But I just finished doing a workout. You can check me out on Instagram if you want to follow my workouts, but nothing too intense. Actually, it was very intense, but not like impressive per se. I was just doing a lot of things. So I'm a little bit tired from that. On top of on top of the fast. So yeah. So let me know. We'll see how Larry does Leetcode when fasted, or fasting even. All right, let's do this. Hope everyone's doing it. Hope everyone's having a good week, by the way, a great week even, maybe. It's a little bit rainy here in New York, and yeah, let's jump to it. Enough for the intro. $9.83 minimum cost for tickets. A medium prom. You have planned some train travel 1 year in advance. The days of the year in which you are traveling are given as an integer array days. Each day is 1 to 365. Train tickets are sold in 3 different ways: 1, 7, and 30-day passes, and they cost different amounts. The pass allowed that many days of consecutive travel. So if you have a 7-day pass, then then you could do 7 inclusive. I don't know why I said inclusive. I guess it's just 7 days, right? Okay. So then now you're trying to minimize, I suppose. Yeah, minimize the number. Okay. And days. What is? Okay. I see. So these are the days that they're traveling. Okay. Now I just wanted to, because for a second I thought that the input was going to be something like, almost like a Boolean array of 365 elements. But I guess this makes more sense. Okay. I mean, I'm trying to think whether so there is my immediate thought is that there's a dynamic programming solution for sure. And I guess now that I think about it, because of yesterday's DP. It probably is, but before that, or maybe after that, but before implementing it, I think during a contest, to be honest, I would definitely jump into the dynamic program because I know it. I could code it in a few minutes, and or whatever. On an interview, it's a little bit tricky because I'm just trying. Well, I will articulate the things that I'm talking to you now, maybe in a slightly different way, in a conversationally, but I'm thinking whether there is a greedy-ish solution, My intuition is probably not, but I don't even mean like a greedy as in like a pure greedy, but just maybe something that is, I don't know, maybe not then. I don't know, nothing really comes to me. Something that, this basically, is that true? I want to say that this basically is, is that true? I want to say this is basically like a knapsack, but maybe that's not quite precise. That's why I'm hesitating a bit. I'm just telling you a bit. But in any case, the idea is still very similar in that it is going to be pseudo polynomial in the complexity, meaning that it is polynomial depending on the range of the numbers, right? And in this case, there's 1, 7, and 30, and 365 being the constants that are relevant, perhaps. Okay. I'm trying to think whether. So right now for implementation, I'm just trying to think whether I want to do it as an array of 365 elements, or maybe manipulate this. The beauty about the trade-off rather is that. The beauty of the 365 element array thing is that it's harder to get wrong. If you kind of manipulate the days as is, it's definitely easier to get wrong. In that they're like off by ones, and maybe not, but but that's how I usually try to think about these things when I think about it. Because and some of this may not apply to you in the sense that I've solved many thousands of problems. So for me, I know my strengths and weaknesses, and I know what kind of things that I make silly mistakes on, or have like a tendency to, and I try to avoid them, right? At a certain point, I gotta learn who I am, right? So that's kind of like a little bit of that commentary, but yeah. Okay. Let's do it the silly way first. And how do I want to think about this? Right, sorry, rubbing my eyes a little bit. I think the recurrence should be relatively straightforward, right? There is some minor optimizations that you can make, but basically your recursive function, I think it's going to do something like calculate min, say, the current day, and that's it, really, right? Yeah, I think so. And then in this day, if, and here we'll maybe say used is equal to set of days, right? So basically, the idea here, one kind of not greedy per se, but or not greedy in its pure sense. I say this with a lot of nuance because in dynamic programming is built off this idea of like local maxima type thing, right? Where you're able to make a decision based on the current state, and in that sense, in that particular time, very often that step is greedy in itself. Of course, you're greedying over a lot of exhaustive search in a way, by reusing states, or what's it called, overlapping subproblems or something. But yeah. So basically, the thing that I'm going to try to do today, for this particular one, not for today, but just like for this day is what I mean, is that we only want to buy a ticket if we need to travel on that day, right? Hope that makes sense because, you could go in both directions really in this one, I think, in that it's symmetric. But basically, for example, if you want to buy a 30-day pass, you want to buy, and the days are like 10 and 20, you want to buy the 30-day pass as late as possible, right? I think that makes sense. Like in real life, you're not going to buy it on day one, just in case you need it more, then, you buy it on day 10 so that, you kind of have, you want to bracket it as much as you can. And of course, you could go the other direction, but the idea is still the same. So then now we can do something like, maybe traveling is better. If day is in traveling, right? Because if not, then we just calculate min of day minus 1. And in this case, I guess I'm going backwards, right? Yeah. If day is traveling, that means we have to buy a ticket. Then we have three decisions to make. One is, the three decision is what it sounds like, which is buying a 1-day ticket, a 7-day ticket, or a 30-day ticket, right? So basically, we have, I don't know, day 1 maybe ticket, or ticket 1 maybe, I don't know. Is equal to calculate min of day minus 1 plus costs of 0. Ticket 7 is equal to calculate min of day minus 7 plus cost of 1. And then ticket 30 is equal to calculate min of day minus 30 plus cost of 2, right? And of course, we have to get the base case. So if day is not available, then we just return 0 because we're done with the trip, or with the buying of tickets anyway. Of course, in this case, we return the min of ticket 1, ticket 7, and ticket 30. And that's pretty much the answer. And we start at 365, say, or you could even start by max of days. I think that's probably fine as well. Yeah. Yep, so it looks good. That's submit right now. Just kidding. Of course, if we talked a lot about dynamic programming, so of course it is a dynamic programming portion. So you have to, because this just this just branches out exponentially if you don't cache it, right? But the idea is the idea behind memoization and a core part of dynamic programming is this idea. Well, they're similar, but the idea behind memoization in particular, in specific, is that if you're giving a function and for every same input that you get, you have the same output, then you're Gucci, right? So then you should like save it so that next time you do it, you don't do the expensive thing, right? And day, of course, could go from 0 to 365, and it's going to take O of 1 time per day and O of 1 space per day. So we're pretty good. This is, let's say, D, then it's going to take O of D time in total and O of D space in total. And of course, this is like I said, pseudo-polynomial is what I mean to say. You can also say, depending how you want to phrase it exactly, this is linear in the size of days, just because days is also bound, the array of the size of the array is also bound by 365 or D. So I don't know how you want to phrase it, but as long as you're able to communicate it to your interviewer, that should be fine. But yeah, the way that I always do these, especially for video, is just I guess max days. And this bound is because that's just the max input that we can put in, right? So, and in fact, we do it very immediately. So then now, if has, I think I did need to, I was gonna say I need a +1, but actually I already did it. Thank you, Larry, from 10 seconds ago. Yeah. Otherwise, yeah. Just the casing is inconsistent. I feel really bad about it, but that's because Leetcode does it this way. I like kebab case, or not kebab case. Is it camo? I don't know. I'm confused. So yeah, but in any case, oops, how did that happen? And that's pretty much what I have with this one, I think, unless I'm getting it wrong. I knew I thought I needed a paren, but I was trying to gamble being lazy. Alright, fine. Let's give it a submit. Hopefully this is not wrong. All time limit exceeded? Shouldn't be. Did I miss something? Oh, why did I set this to false? I am being a silly bird today. Usually I check it, but I don't know. I blame it on the fasting and the brain fog or whatever. I don't know. It's not even true. I don't know why I wrote false. That is such a brainly bad thing. And I've done this like in 1,000 videos, and I think this is the first time I've gotten this wrong, so it's a little bit embarrassing. But I mean, I'm not that embarrassed. Mistakes happen, and I was talking, so yeah. But yeah, we already talked about the complexity, so that's what I have with this one. Let me know what you think. Let me know if this helped out in your dynamic programming journey. And yeah, that's what I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.